Of course, one of the nice things about these properties of logarithms is that we don't only use them to take single logarithm expressions and split them up as sums or differences. We can go the other direction and take a sum or difference of logarithms and change it, rewrite it into the single logarithm of a single quantity. Let's take, for example, this first one. We're told to condense the expression 2 natural log of 8 plus 5 times the natural log of z minus 4 into the logarithm of a single quantity. Well, in this case, we would start with our power rule because we want to get rid of these numbers that are right here in front of our logarithms and put them in a manner that's going to help us out. So we could take this and rewrite this as our natural logarithm of 8 squared and add that to our natural logarithm of z minus 4 to the fifth power. Now, we want that because if we have logarithms that we're adding, the logarithms have to be by themselves, right? Remember, there's no multiplier in front of these logarithms, so we couldn't combine them unless we actually did move those exponents in front. And so our next step right here, aside from rewriting 8 squared as 64, is to remember that since we're adding, we're actually taking the product, right? If we're going backwards, we're taking the product of these two logarithms right here, the arguments of those logarithms. So it's like saying it's the natural logarithm of 8 squared, which is to say 64, times z minus 4 to the fifth. And this is a logarithm of a single quantity, and we consider this simplified in that sense. How about that next one? Here we've got 3 log x minus log y plus log z. We've got three things going on at once. Well, I'll tell you, whenever you have a multiplier in front of one of these logarithms, your very first job should be to rewrite that logarithm by getting rid of that multiplier. So in this case, we can see right away, at least hopefully, that we're going to get a logarithm. We're using a common logarithm in this particular case, a common logarithm of x to the third. Now I'm going to do one other thing. If I have a subtraction in my group of terms that are added together, I'm going to try and put that last. So I'm actually going to switch the order right here. And we're going to be adding this to the logarithm of z. And then subtracting from all of that the logarithm of y. Well, that's not bad because now we can just go step by step, and let's use it a rule at a time. We see that we have our product rule up front here, and we can rewrite that as a logarithm of the quantity x cubed times z. And we will be subtracting from that the logarithm of y. So now if we want to combine these together, we have to go to our quotient rule. And our quotient rule, remember, it's a logarithm of u minus a logarithm of v. And where you're going to combine these by using our division. So this is going to become a logarithm of the quotient x cubed times z divided by y. All right, so let's do one last one. This time we're going to combine. We've got three things subtracted in a row. Oh my, what should we do? Well, of course, we have this multiplier down in front right here of the natural log of z. We should take care of that first. So let's rewrite that by getting rid of those exponents. We're going to take the natural log of x minus the natural log of y minus the natural log of z to the 1/2 power. All right. Now, one thing, if I don't want to have a division divided by another division right here, I'm going to rewrite this very briefly by factoring out a negative sign from the two last terms, so that I have the natural log of y plus the natural log of my square root of z. You recognize that z to the 1/2 is the square root of z, right? Okay, so what could we do? Well, let's work from the inside out. Now that I've only got one subtraction symbol, that's sort of my goal when I rewrite this, just get one subtraction symbol. What am I subtracting? Well, this has got to be a single logarithm. So by my product rule, this is the same thing as saying the natural logarithm of y times the square root of z. And then by our division rule, our quotient property, we can rewrite this one more time as the natural logarithm of x divided by y times the square root of z. And there you go. This is a simplified logarithm of a single quantity as you're going to get from this expression. And we're done.